Hi, welcome back. In the last video, we looked at part 0A of the full stack open curriculum. Now we're going to continue on with part 0B. So I'm going to read through all the information provided here up to the exercises, and I'll leave the exercises for 0.1 to 0.6 to the next video. So let's begin. Before we start programming, we will go through some principles of web development by examining an example application at here. So let's open up this link. Okay, so I'll just quickly go out of dark mode. So this is what it probably looks like for you. So we have number of nodes created 100. Just click the nodes. Okay, so these are all the nodes that have been entered. Um, okay, we'll just do a test. So it looks like the testing one is the latest one at the bottom here, which I just entered. So that's the example application. Let's go back. The application exists only to demonstrate some basic concepts of the course and is by no means an example of how a modern web application should be made. On the contrary, it demonstrates some old techniques of web development, which could even be considered bad practices nowadays. So this is just to give you some background knowledge on uh, how a basic um, web application was made, probably um, back when things were probably a bit more simpler. There are better and more modern ways of building web applications now. This is just a sort of quick and simple example in the beginning. So code will conform to contemporary best practices from part 1 onwards. Okay. Open an example application in browser. We've already done that. Sometimes this takes a while. The course material is done with the Chrome browser. The first rule of web development, always keep the developer console open on your web browser. On Mac OS, open the console by pressing function F12 or option command I simultaneously. On Windows or Linux, open the console by function F12 or control shift I simultaneously. The console can be opened via the context menu. So I like to go into the app and just click inspect, and that brings up this here, and I just go to the console. Um, yeah, so it looks like the console logging the array, but I'm getting a little bit ahead of some. So this is basically a way of opening up the web console. Remember to always keep the developer console open when developing web applications. The console looks like this. Okay, great. Yep, so make sure the network tab is open. Yeah, we've got that open now. And check the disable cache option as shown. Preserve log can also be useful. It saves the logs printed by the application when the page is reloaded, as well as hide extension URLs. Hides request of any extensions installed in the browser, not shown in the picture above. So I do have some extensions installed. For example, these ones here and the dark reader. Um, so this is just to prevent those ones, prevent these extensions from sending out requests. Um, okay, so we're going to follow the instructions and disable the cache uh, here. So preserve log is useful, but they didn't say that we need to check that one. Let's just go down to the next section. So HTTP GET. The server and the web browser communicate with each other using the HTTP protocol. The network tab shows how the browser and the server communicate. When you reload the page to refresh a web page on Windows, press the function F5 keys. On macOS, press Command R or press the reload symbol on your browser. The console will show the two events that have happened. Okay, so let's do hide extension URLs because I do have some other extensions on my browser. I am using Brave web browser, which is sort of spun off from Chrome. It's just a more privacy focused browser, so it's quite similar to Chrome, so we can just use that for now. Okay, let's click the refresh. I just drag this up a little bit. The browser has fetched the contents of the page uh, from the server and has downloaded the image Kuva PNG. Okay, I think we're in the wrong page. If we go back, yes, here we go. Here is the Kuva PNG. So just to reiterate, we need to, yes, so we need to fetch the contents of the page for this URL here. I was in the notes one beforehand, so I've gone back and now I have the Kuva PNG request in the network tab. Okay, so on a small screen, you might have to widen the console window to see these. Click the first event. Clicking the first event reveals more information on what's happening. Let's go to the first one and then headers. Yep. Okay, the upper part, general, shows the browser requested the address. Yep, here we go. And though the address has changed slightly since the picture was taken using the get method, and that the request was successful because the server response had the status code of 200. So if we go to general, you can see that here we have the request URL, like so. There's the get request method, and the request was successful. We did get a response with the status code of 200, which means that it's okay and it's green. So it was a success. The request and the server response have several headers. Let's go to the headers, response headers, and the request headers and the response headers. The response headers on top tell us, e.g., the size of the response in bytes and the exact time of the response. An important header content type tells us that the response is a text file in UTF-8 format and the contents of which have been formatted with HTML. This way, the browser knows the response to be a regular HTML page and to render it to the browser like a web page. So, I think the main thing that they're pointing out here is the content type, which is text/HTML, and it's using the char's character set UTF-8, which is sort of the standard one that I've seen being used. So on our actual web page in the console, it's here. So it's the content type, text/HTML, and the char set is UTF-8-8. Okay, so the response tab shows the response data, a regular HTML page. The body section determines the structure of the page rendered to the screen. Let's go to the response, and here we go. Here's the HTML. The page contains a div element, which in turn contains a heading, a link to the page notes, and an image tag, and displays the number of nodes created. So because of the image tag, the browser does a second HTTP request to fetch the image kuva.png from the server. The details of the request as follows. Let's just quickly look. So as I said, there's a div with the class of container, a heading, a paragraph text, a link, and the image, which I'm thinking it's this one here. Yes, so if we go into a new tab, Yes, you see that it's curva.png. So that's the same image there. And again, let's look at the second request, which is looking for the image. The request that was made to the address here, and then its type is HTTP GET. The response headers tell us that the response size is 89,350 bytes, and its content type is image/PNG, so it is a PNG image. The browser uses this information to render the image correctly to the screen. And we have the same information here. So there's the size of the image type, and some other data there as well. The chain of events caused by opening the page on a browser on this page on a browser forms the following sequence diagram. And here is a link to show what a sequence diagram is. We probably don't have time to look through this. If you're interested, um, you can take a look. But I think it's just a way to show how a sequence of events occurs um, for the different responses between the browser and the server. So the sequence diagram visualizes how the browser and the server are communicating over the time. The time flows in the diagram from top to bottom. So the diagram starts the first request that the browser sends to the server, followed by the response. Yes, so uh, time goes downwards as the first event is getting the page, sending the request for the page, which then the server responds with the HTML document of that page. And then because within the HTML document there is a um, note for a image, so then the browser goes and gets that image through a second request, as we've actually seen here. Gets the HTML first and then the image. And finally, the server returns with the picture, which then gets rendered onto the browser. Yes, even though it's difficult to notice, the HTML begins to render before the image has been fetched from the server. In other words, um, this text and this link actually gets rendered first before the image gets loaded. Um, this is less noticeable now because internet speed have been um, increased over the years. So probably in the 90s, back when everything was still in dial-up, it was more easier to notice that as you load a page, slowly the image would start to load and incrementally get rendered. Traditional web applications. The homepage of the example application works like a traditional web application. When entering the page, the browser fetches the HTML detailing the structure and the textual content of the page from the server. The server has formed this document somehow. The document can be a static text file saved into the server's directory. The server can also form the HTML documents dynamically according to the application's code. Using, for example, data from a database, the HTML code of the example application has been formed dynamically because it contains information on the number of created nodes. The HTML code of the homepage is formed dynamically on the server as follows. So it looks like this is the server code. Um, so it's just the template string, and um, here is a parameter which you can then input how many nodes there are dynamically as um, as this sentence here has described. And this is where we have the bit of code that controls when a browser requests the homepage, what it should do. And so the response is to create a page using the get front page HTML function with notes.length as the number of notes that exist, and then we send it back to the browser with this line of code here. You don't have to understand the code just yet. I just quickly explained um, what this part does, but yeah, so it's doesn't matter too much at the moment if you um, don't fully grasp what's happening here. The content of the HTML page has been saved as a template string or a string that allows for evaluating, for example, various variables like node count. In the midst of it, the dynamically changing part of the home page, the number of saved nodes in the code node count is replaced by the current number of code nodes in the code nodes.length in the template string. Writing HTML amid the code is of course not smart, but for old school PHP programmers, it was normal. It was a normal practice. In traditional web applications, the browser is dumb. It only fetches HTML data from the server, and all application logic is on the server. A server can be created using Java Spring, Python Flask, or Ruby on Rails, to name just a few examples. The example uses Express library with Node.js. This course will use Node.js and Express to create web servers. Yes, so Node.js is just a way to run JavaScript on the server side, and Express is a framework that's quite widely used to make creating servers with JavaScript on the Node runtime a bit easier. You can actually do it with pure Node.js, but that takes a bit more effort. So running application logic in the browser, keep the developer console open, empty the console by clicking the this symbol here or by typing clear in the console. Now, when you go to the notes page, the browser does 4 HTTP requests. So let's click this button here, and that cleared out the requests. Okay, so we're going to the notes page now. Let's go there. Yes, see, as you may have noticed, the notes page was requested first, and then there was a slight delay, and finally these CSS main.js and the data was loaded in. So that's similar to what the previous one of the previous sections was talking about, how the image loaded um, later on than the actual HTML. So it's always the first thing is the HTML gets requested, and when it comes back, it will make further requests as necessary. All the requests have different types. The first request type is document. It is the HTML code of the page and it looks as follows. So similar to the previous page, we can look at it by clicking here, and here again there's the text slash HTML to denote that it's an HTML document. We notice that the code does not contain the list of nodes. The head section of the HTML contains a script tag, which causes the browser to fetch a JavaScript file called the main.js. The JavaScript code looks as follows. So here is the main.js. If we look at the preview, you can see the code for this JavaScript file. It's creating a, this is the bare bones way of creating a request to make to the server. Um, So in modern browsers, we are able to use a fetch API, which makes things a bit more simpler. Um, I think they'll probably mention it that somewhere down here. So, okay. The details of the code are not important right now, but some codes have been included to spice up the images and the text. We will probably start coding in part 1. The sample code in this part is actually not relevant at all to the coding techniques of this course. Some might wonder why HTTP-object is used instead of the modern fetch. Yeah, so I mentioned the fetch API before. This is due to not wanting to go into promises at all yet. Ah, okay, I see. And the code having a secondary role in this part. We will return to modern ways to make requests to the server in part 2. So all you need to know is that this is an older way of making a request to the server. Um, we will be using the fetch API when we get to part 1. And yeah, so this is just a simple introductory way, um, and most modern practices wouldn't use this technique. Um, yeah. Okay, so immediately after fetching the script tag, the browser begins to execute the code. The last two lines instruct the browser to do an HTTP GET request to the service address /data.json. So these last two lines. Um, So it's going to, it looks like it's going to this endpoint to get the JSON data, um, and then it sends the whole request that's been created here. Um, so it looks like the notes HTML first gets requested and then comes back. And then the browser reads through the notes HTML as it loads and realizes that it has to fetch the main.css and the main.js files. And as it's running through the main.js files, there's a sequence of code that tells the browser to get the data as well from this fetch request. Oh, yes, from this request. Yes, the last two lines instruct the browser to do an HTTP GET request to the service address data.json. This is the bottommost request shown on the network tab. We can try going to the address and straight from the browser. Yes, so I have an extension, browser extension to prettify the mm, data. So here's what it looks like raw. It's just one long line of a array of objects like so. If we go back, if we refresh, yes, so it should go back to the parsed version, which just makes things much easier to look at and see what each piece of data is. So we can try, and then there we find the nodes in JSON raw data. By default, Chromium-based browsers not too good at displaying JSON data. Plugins can be used to handle the formatting. So plugins is just another word for extensions. Install, for example, JSON view on Chrome and reload the page. The data is now nicely formatted. Yep, so that's what it looks like here as well. So the JavaScript code on the nodes page above downloads the JSON data containing the nodes and the and forms a bullet point list from the node contents. This is done by the following code. So here it's just this part here. It's just the same as this part here. Yeah. The code first creates an unordered list with a UL tag. Yep. So we have it here as well. So URL equals document.create element URL. URL just stands for unordered list, and so then we set the attribute class notes. So um, it's essentially adding a class with the value notes, and then adds a li tag for each node. Li stands for list item. Only the content field of each node becomes the contents of the li tag. The timestamp found in the raw data are not used for anything here. Okay, so these timestamps are simply there to um, discern when the node was added in the app. In terms of rendering, it's only the content here that's being rendered. Now open the console tab on your developer console. So let's go here, and you see the same data as the ones shown here. So by clicking the little triangle at the beginning of the line, you can expand the text on the console. Mm, by clicking the little triangle at the beginning of the line, you can. So I've already done that. It's just this little triangle here, and then the output on the console is caused by the console log command in the code. So here is the console log data. So after receiving the data from the server, the code printed to the console. The console tab in the console log command will become very familiar to you during the course. Yes, console log is quite a useful tool to debug problems in the code. Mm, yes. So that's something that you will use quite regularly throughout your coding journey. Event handlers and callback functions. The structure of this code is a bit odd. The request to the server is sent on the last line, but the code to handle the response can be found further up. What's going on? The request to the server is sent on the last line, but the code to handle the response can be found further up. So this is where it's handling the response. In other words, they're saying that it should be that to have it send here and then have it respond after the browser gets the response from the server. On this line, an event handler for the event on ready state change is defined for the XHTTP object doing the request. When the state of the object changes, the browser calls the event handler function. The function code checks that the ready state equals 4, which depicts the situation. The operation is complete, and that the HTTP status code of the response is 200. So it only really starts handling the uh, running the code for the response if it's ready and if the response came back successfully with a 200 um, status code. The mechanisms of invoking event handlers is very common in JavaScript. Event handler functions are called callback functions. The application code does not invoke the functions itself, but the runtime environment, the browser, invokes the function at an appropriate time when the event has occurred. So this is just explaining why we have the uh, block of code dealing with the response um, before actually the command to send the response itself. Document Object Model or DOM. We can think of HTML pages as implicit tree structures. Here is the structure here of the document that we're looking at. The same tree-like structure can be seen on the console tab elements, which is here. So here is the tree structure as described. Um, the same tree line. Okay, so the functioning of the browser is based on the idea of depicting HTML as a tree. Document Object Model or DOM is an application programming interface or API that enables programmatic modification of the element trees corresponding to web pages. The JavaScript code introduced in the previous chapter used the DOM API to add a list of nodes to the page. The following code creates a node to the variable UL and adds some child nodes to it. So this is the variable. Um, and then this is the DOM node for the unordered list. And then there's a loop that creates a list. Each iteration of the loop, we have a list item assigned, a list item DOM node assigned to the li variable, and then we append this li variable to the unordered list DOM node, and then we append the node, which is the node content, which is the text of that node, to the list item. It's basically just a way of rendering out the lists from the data. Finally, the tree branch of the unordered list variable is connected to its proper place in the HTML tree of the whole page. So yes, we just then append the unordered list to the nodes ID page, which is this div here. So to show you what this code is doing visually, first this gets created and then assigned to a variable called unordered list or UL, and then it loops through uh, the data and then assigns each of these to a variable, a temporary variable called li or list item, and then it appends it to this unordered list here. So that's rendering each of these list items sequentially through a loop. And finally, we then append this unordered list to this notes div. Okay, so I think we might actually stop here. I know that I mentioned that we're gonna go all the way to the exercises, but I sort of underestimated how long going through this section was gonna be. So we'll just take a break here and then continue on with manipulating the document uh, object from the console. And yes, in the next video, we're going to go through this section here down to JavaScript fatigue, and then uh, in the subsequent video, we will continue with the exercises. Thanks for watching. See you in the next video.